Hi everyone, welcome back to the AI Academy. Today, we are diving into our Business Analytics for Management Decision course. Our topic for today's lecture is all about data visualization. We will cover things like data visualization, its architecture, its key principles and techniques used in it, tool used and so. Let's start today's lecture discussing on data visualization. It is a graphical representation of data or information in a way that makes it easier to understand, analyze, and communicate insights. It involves using various visual elements, such as charts, graphs, maps, and diagrams, to present complex data in a more accessible and intuitive manner. It is an essential tool for exploring and making sense of large and complex datasets, as well as for effectively communicating findings to others. The primary goal of data visualization is to transform raw data into a visual format that highlights patterns, trends, and relationships that may not be immediately apparent from the raw numbers or text. By presenting data visually, it becomes easier to identify outliers, spot correlations, and uncover insights that would be difficult to discern from tabular or textual representations. It is widely used across various domains, including business intelligence, scientific research, journalism, and data analytics. It plays a crucial role in communicating complex information effectively, supporting decision-making processes, and enabling stakeholders to gain valuable insights from data. With the increasing availability of powerful data visualization tools and libraries, such as Tableau, Power BI, etc., it has become easier for both technical and non-technical users to create compelling visualizations and tell data-driven stories. However, it is important to remember that it is not just about creating pretty pictures, it is about using visual representations to effectively communicate insights, support analysis, and drive informed decision-making. There are several key principles and techniques used in data visualization. First and important one is choosing the right chart type. Different types of charts and graphs are suitable for different types of data and the stories we want to tell. For example, line charts are useful for showing trends over time, bar charts are effective for comparing categories, and scatter plots are suitable for displaying relationships between two variables. Next is, leverage visual encoding, which involves using visual properties, such as position, size, color, and shape, to represent different dimensions of the data. Effective visual encoding can make patterns and relationships more apparent and easier to perceive. Then next is, utilizing color and contrast. Color can be a powerful tool for distinguishing different elements, highlighting important areas, or conveying additional information. However, it is important to use color judiciously and ensure sufficient contrast for accessibility and clarity. When we talk about maintaining clarity and simplicity, we can say that data visualizations can be highly complex. It is important to maintain clarity and simplicity whenever possible. Cluttered or overly complicated visualizations can be difficult to understand and may obscure the underlying message. Next is provide context and annotations. Contextual information, such as titles, labels, legends, and annotations, can help viewers better understand the data and the insights being presented. Consider interactivity includes interactive visualizations, such as those with filters, tooltips, or drill-down capabilities, can enhance exploration and discovery, allowing viewers to engage more deeply with the data. Let's discuss about the tools for data visualization. First, we will start with Tableau, which is one of the popular tools for creating interactive and shareable dashboards. Next is Power BI, which is the Microsoft's business analytics tool for visualizing data and sharing insights. D3.js is a JavaScript library for producing dynamic and interactive data visualizations in web browsers. Matplotlib is a Python plotting library for creating static, animated, and interactive visualizations. And ggplot2, which is an R package for creating elegant and complex plots. Going on to the next topic, types of data visualizations. While talking about charts and graphs, charts are used as an analytical tool. They are one of the most commonly used tools in data visualization. They provide a graphical representation of data, making it easier to identify patterns, trends, and relationships that may not be immediately apparent from raw numbers or text. There are various types of charts, each suited for different types of data and purposes. In this section, we will explore several popular chart types and their uses in detail. We can see different types of charts in the Insert menu. Some of the different types of charts are column charts, line charts, pie diagrams, bar charts, area, scatter, and so on. First, we will start with line charts that are ideal for displaying data that change over time, such as stock prices, temperature readings, or sales figures. It effectively illustrates trends, cyclical patterns, and the rate of change within the data. Let's see step in Excel how to select line charts. First, click on the Insert tab. We can see different chart. Select the chart according to the requirement as shown in figure. They consist of one or more lines, each representing a distinct data series, plotted on a horizontal x-axis and vertical y-axis. There are 6 types of line charts. Let's discuss one by one. First, we will start with line. It displays trends over time like dates, years, or ordered categories. It is useful when there are many data points and the order is important. Line with markers. It displays trends over time or order categories like line, but it is useful when there are a few data points. Stacked line. It displays the trend of the contribution of each value over time or ordered categories. It considers using stacked charts instead. Next is stacked line with markers. This is similar to the stacked line chart but will highlight data points with markers. 100% stacked line. It displays trend of the percentage each value contributes over time or ordered categories. It considers using a 100% stacked is chart instead. Then comes 100% stacked line with markers. It is similar to the 100% stacked line chart but with additional markers on each data point. Picking the best chart for our data is important. There are different charts for different situations. The above description helps us to select our charts. Let us take an example of line charts in which the graph of sales is shown. In this, the sales have up and down in different months. This line chart shows the sales amount from January to May. Each point on the line represents the sales amount for a specific month. We can see that in January sales were the highest, around 6,000 units. In February sales dropped to about 4,000 units. Again in March sales increased slightly around 5,000 units. In April sales decreased again, to around 3,000 units. In May, sales continued to decline, reaching around 1,000 units. Overall, the chart indicates a downward trend in sales over these 5 months. Next is bar charts, which works really well for comparing various data categories or groupings. They are made up of rectangular bars whose lengths correspond to the values they stand for. Inserting the bar chart. Go to the Insert tab in the Excel ribbon. In the Charts group, click on the bar chart icon. Select the style of bar chart we want, example, clustered bar for standard vertical bars or stacked bar. We can also customize the chart. After the chart is created, we can customize it. We can select chart title to change it. We need to click the chart title to change it, example, sales by product. To add or edit the axis titles by clicking on the chart and selecting chart elements, the plus icon, then checking axis titles. To colors and styles we use the Chart Tools ribbon, which appears when we click the chart, to change colors, styles, and other visual elements. To display the values directly on the bars, click on the chart, go to Chart Elements, the plus icon, and select Data Labels. They are particularly helpful for visualizing and comparing quantitative data across several categories, such as sales figures for various items or survey results. They can be positioned horizontally or vertically. Let's take an example to understand more. In the figure, the bar chart compares the sales of two types of clothing, ethnic clothes that is, blue bars, and Western clothes that is, red bars, from January to June. We can see that in January the sales of ethnic clothes and Western clothes are roughly the same, around 1,000 units each. Whereas February the sales of Western clothes are higher than ethnic clothes. In March both ethnic and Western clothes have similar sales, around 1,500 units each. In April sales of Western clothes peak at 5,000 units, significantly higher than ethnic clothes, which remain at 1,000 units. Overall, Western clothes generally have higher sales than ethnic clothes, with some months showing significant differences. Let's learn about pie charts and where it is used. They are circular charts divided into slices, where the size of each slice represents the proportion of the whole for a particular category. They are commonly used to show the composition or breakdown of a whole into its constituent parts, such as market share, budget allocation, or population distribution. Let's take an example of pie chart. In this figure we can see out of total students, number of student taken science is represented by blue color whereas number of student taken art is red and number of student in commerce is green. The whole circle represents the total number of student. Let's check its advantages. Simple visualization that is easy to understand and interpret at a glance. Useful for comparing proportions between different categories. Visually appealing and can make a presentation more engaging. Disadvantages of pie charts. Not suitable for large datasets or datasets with many categories. Difficult to compare slices that are similar in size. Can be misleading if the slices are not proportional or if 3D effects distort the sizes. When to use a pie chart. Part-to-whole relationships means when there is need to show how different parts make up a whole. Best used when there are fewer than 7 categories. Too many slices can make the chart hard to read. When the focus is on the relative sizes of the parts rather than precise values. Let's now discuss about scatter plot. It is also known as a scatter chart, scattergram, or scatter graph, which is a type of data visualization that displays values for two variables for a set of data. They are used to display the relationship between two quantitative variables. Each data point is plotted as a coordinate pair on a Cartesian plane, with the x-axis representing one variable and the y-axis representing the other. It can reveal patterns, clusters, and correlations within the data, making them valuable for exploratory data analysis and identifying potential relationships between variables. There are different types of scatter in Excel. We can select according to our requirement. Components of a scatter plot. Title describes the content of the scatter plot. X-axis represents the independent variable. Y-axis represents the dependent variable. Data points is a point in which each point on the scatter plot corresponds to a pair of values, x, y, from the dataset. Grid lines means optional horizontal and vertical lines that help in interpreting the plot. Legend multiple datasets are plotted on the same graph. Let's see the types of relationships it has. Scatter plots can reveal several types of relationships between variables. Positive correlation in which one variable increases, the other variable also increases. Points trend upwards from left to right. Negative correlation is the one in which when one variable increases, the other variable decreases. Points trend downwards from left to right. No correlation in this there is no discernible pattern, the variables do not show any apparent relationship. Nonlinear relationship in which the relationship follows a curve rather than a straight line. Let's learn about histograms. They are similar to bar charts but are used to display the distribution of a single continuous variable. They consist of adjacent rectangular bars, where the height of each bar represents the frequency or count of data points falling within specific ranges or bins. They are useful for visualizing the shape of a data distribution, and detecting potential outliers. Components of a histogram. Title describes the content and focus of the histogram. X-axis that represents the continuous range of data values, divided into intervals, that is, bins. Each bin represents a range of values for the variable being measured. Y-axis, which represents the frequency, count, or density of data points within each bin. Bins, which mean the range intervals on the X-axis that group the data. Bars are rectangles whose heights correspond to the frequency or density of data points in each bin. Here, the X-axis is divided into 4 bins, intervals. Below 20. 20 to 30. 30 to 40. 40 to 50. Each bin represents a range of values for the variable being measured. The Y-axis represents the number of occurrences, that is, frequency, for each bin. The scale on the Y-axis goes from 0 to 25, with intervals of 5. Interpretation. In below 20, the bar reaches up to 5, indicating there are 5 occurrences in this range. In 20 to 30, the bar reaches up to 10, meaning there are 10 occurrences in this range. In 30 to 40, this bar is the highest, reaching 20 on the Y-axis, indicating that 20 occurrences fall within this range. This suggests that the 30 to 40 range has the highest concentration of occurrences. In 40 to 50, the bar reaches up to 15, showing that there are 15 occurrences in this range. Summary. The highest frequency of occurrences is in the 30 to 40 range, with 20 occurrences. The range with the fewest occurrences is below 20, with only 5 occurrences. The data appears to have a peak in the 30 to 40 range, suggesting that most occurrences fall between 30 and 40, while fewer occurrences are found in the below 20 and 20 to 30 ranges. This histogram helps visualize the distribution, making it easy to see that the 30 to 40 range is where most of the data is concentrated. Types of histograms. Normal distribution that shows a bell curve, indicating that most data points are centered around a mean value. This type of histogram is symmetrical. Next is bimodal distribution, which has 2 peaks, indicating 2 commonly occurring values or 2 different groups in the data set. Then comes skewed distribution. Data may be skewed left, that is, left tail is longer, or right, that is, right tail is longer, showing that the majority of values are concentrated on one side. Uniform distribution, in which all bins have roughly the same height, indicating that all values are equally likely. Finally, multimodal distribution that contains more than 2 peaks, indicating multiple common values or groups within the data. Uses of histograms. First is identifying patterns. It makes it easy to spot patterns or distributions in data, such as normal, skewed, or bimodal distributions. Next is detecting outliers, in which outliers appear as isolated bars, making it easy to identify values significantly different from the rest of the data. Analyzing processes in quality control comes next. In manufacturing and quality control, histograms are used to ensure that processes produce consistent and acceptable outcomes. Finally, decision-making in business. Histograms help businesses analyze customer data, sales trends, and process performance. Advantages of histograms. Simple and intuitive. They are easy to create and understand, providing a quick visual summary of data distribution. Clear data representation. They are ideal for displaying large amounts of data clearly and concisely. Effective for continuous data. They work best with continuous, numerical data, making them suitable for scientific and statistical analysis. Limitations of histograms. Bin width sensitivity. Choosing bin width can be tricky. Too wide bins may hide patterns, while too narrow bins may make the histogram hard to interpret. Limited to quantitative data. They don't work well for categorical data. Comparing multiple data sets. They are best suited for single data sets. Comparing multiple histograms can be visually complex. Let's talk about area chart. They are similar to line charts but use filled areas to represent the magnitude of the data. They are particularly useful for visualizing the contribution of different components to a whole over time or for comparing the cumulative values of multiple data series. Let's check when to use an area chart. Trend analysis over time. They are ideal for showing how values evolve over time, especially when tracking changes in volume. While comparing multiple categories. When the volume or quantity of data is as important as its trend, it highlights the magnitude of values due to the shaded areas. Advantages of area charts. First is, easy to interpret trends. The filled area helps emphasize the trend, making it easier for viewers to see upward or downward changes in data. Good for showing parts of a whole that is in stacked and 100% stacked formats. It provides a visual representation of the contribution of different components to a total. Ideal for high-level data summaries. It effectively summarizes large datasets into digestible visuals, allowing quick understanding of trends. After advantages, let's go through its disadvantages. First is, overlap can lead to misinterpretation. In stacked area charts, the overlapping sections can sometimes make it hard to compare individual categories accurately. Next is, limited precision. They may lack the precision of line charts, as exact values are harder to pinpoint. Not suitable for many categories is also one of its disadvantages. With multiple categories, the chart can become cluttered, and readability suffers. Types of area charts. Simple area chart shows a single filled area. Stacked area chart, multiple series stacked on top of each other. 100% stacked area chart shows relative percentages. And stream graph, a variation with flowing, organic shapes. Our next topic of discussion is bubble charts. They are a variation of scatter plots, where each data point is represented by a bubble or circle. The size of the bubble corresponds to an additional dimension or variable, allowing for the visualization of 3 variables simultaneously. They are often used in financial analysis, demographic studies, and other applications where multiple variables need to be compared. When choosing the appropriate chart type for data visualization, it is essential to consider the nature of the data, the relationships or patterns we want to highlight, and the audience's familiarity with different chart types. Additionally, effective use of visual encoding techniques, such as color, size, and shape, can enhance the clarity and interpretability of the charts. It's important to note that while charts are powerful tools for data visualization, they should be accompanied by clear labels, legends, and annotations to provide context and ensure accurate interpretation. Furthermore, interactive features, such as tooltips, filters, and drill-down capabilities, can greatly enhance the exploratory and analytical capabilities of charts, allowing users to engage with the data more effectively. Let's discuss some more charts available in Excel. Excel is a powerful tool for creating various types of charts, including stock charts. Excel's stock charts are specifically designed to display financial data, allowing users to visualize the performance of stocks over time. This guide will walk us through the process of creating different types of stock charts in Excel, including the high-low close, open high-low close, and volume high-low close charts. Components of stock charts. Title indicates the name of the stock or financial instrument being charted. X-axis represents time, which can range from minutes to years. Y-axis represents price levels or trading volume. Price plot shows the movement of the stock's price. Volume bars display the trading volume for each period, usually shown as bars at the bottom of the chart. Creating a stock chart. Here's a step-by-step guide to creating stock charts in Excel. Enter the data. Ensure the data is in the following format. Select the data to highlight the range of cells that contains our data, including the headers. To insert a chart first, go to the Insert tab on the ribbon. In the Charts group, we have to click on the Insert Stock Chart drop-down. We need to choose the type of stock chart we want to create, that is. First is high, low, and close values. Next is open, high, low, and close values. Then comes volume, high, low, and close values. Finally, volume, open, low, high, close. Let's take an example, creating an open high-low close chart. Select data range that highlight the data range, including date, open, high, low, and close columns. To insert chart, select on the Insert tab. Click on the Insert Stock Chart drop-down. Select Open High-Low Close. Excel will generate a stock chart that visualizes the open, high, low, and close prices for the selected dates as shown in the diagram. Let's check why to use data visualization. First is easier to understand. Visuals make it simple to grasp complex data. Instead of wading through pages of numbers, a quick glance at a chart can tell you the key points. Next is spot trends and patterns. Visuals help us to see trends and patterns that might not be obvious from raw data. For instance, we might notice sales peak during certain months. Then come, make better decisions. Seeing the data clearly helps us make informed decisions. If we see a decline in sales, we can investigate and address the issue. Finally, communicate effectively. It's easier to share and explain your findings with others using visuals. Whether in a meeting or a report, visuals ensure everyone understands the key information quickly. How to create good visualizations. First is choose the right type. Pick the visual that best represents your data. Use bar charts for comparisons, line graphs for trends, and pie charts for proportions. Keep it simple. Avoid clutter. Too much information can be confusing. Focus on the most important data. Use clear labels. Make sure everything is clearly labeled. Axis titles, legends, and data points should be easy to read. Then comes consistent colors. Use colors consistently to avoid confusion. If you use blue for sales in one chart, use blue for sales in all charts. Examples in everyday life. Weather forecasts. The temperature is often shown as a line graph, making it easy to see if it's getting hotter or colder. Fitness apps. These apps use charts to show how many steps you've taken or how many calories you've burned over time. Election results. Maps and charts show which candidate won in different areas, making it easy to see overall results. Let's conclude today's lecture by discussing common pitfalls in data visualization. First is, overcomplicating the visualization. Too much information or overly complex visuals can confuse the audience. Next is, misleading scales. Manipulating axes or scales can distort the data and lead to incorrect conclusions. Then comes, ignoring data context. Failing to provide context or background information can lead to misinterpretation of the data. Inconsistent use of colors. Using too many or inconsistent colors can distract or confuse viewers. Finally, neglecting data integrity. Ensure the accuracy and reliability of the data being visualized. In our next video we will see data analysis. Stay tuned for the next lecture, where we will continue our journey through business analytics courses. If you want any other topic to cover, please let us know. If you have any queries related to this lecture, you can ask in the comment box. We will try to clear all your doubts. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more information on business analytic content. Your support is really important to us and it encourages us to make more educational stuff for you.